In this video, I will be explaining you proposition 9 from section 3.2 sequential pointwise limits and simple approximation. Okay, this proposition is a very important proposition for the semester examinations. So here you can see the statement and this is the proof. To me, when I try to understand the proof of this proposition, I felt very difficult. So what I did is I made a note from this. By mine, I cancelled some of the steps from here, and here I have my notes. Sometimes my notes might be wrong, but I don't bother about it, because if I try to learn this proof, I need to mug up it. I don't want to do that. So I will follow my notes, okay? Without understanding, I don't want to study even one step. Okay, so these are very improper. These lines are. I am not even getting a single hint about what they are trying to convey from this steps. Okay, so I don't follow that. So here you can see my notes. Before that, let me read the statement of this proposition. Let fn, they are given you a sequence of function, and that function is measurable, and this function is on the set E. Okay, you are having this function on the set E. So this sequence of measurable function is converges pointwise almost everywhere on E. It is converging pointwise almost everywhere. So here is a question: what is mean by converges pointwise almost everywhere on E, right? So here you can see the definition for pointwise converges pointwise almost everywhere. You can read this statement. Sorry, you can read the definition for that from here. The sequence Fn, if you want to say the sequence Fn converges to F pointwise almost everywhere on A, provided it converges to F pointwise on A difference B, it means it converges. Okay, this is what their definition. Okay. Even I am not proper about it. I have no proper understanding about it. Okay. Okay, let's see the proof of this proposition. We have two studies, because for examination point of view, this proposition is very important. So we have to learn it. Right. So let's start learning it. So here you can see the proof of this proposition. First, you are assuming Fn, in the statement they are given, right? The sequence of measurable function E is converges pointwise almost everywhere on E. If this Fn is doing that, then we have to say that particular F, that is here the sequence of measurable function F is converges to this F, right? If this sequence of measurable function converges pointwise almost everywhere on E, then we have to prove this F is measurable. So that is what you are going to do. So you are assuming the sentences that you have just before then. Okay. So just assume that. That is what I am writing here. See, Fn converges to F pointwise almost everywhere on E. Assume it, and you are going to prove now F is measurable. Okay. So let's see how they are proving. So that is to prove. If you want to say this F is measurable, you have learned the first proposition that you can see in another video. Okay. If you want to see that video, go and check out my measure and integration playlist. So here you have, if you want to say this F is measurable, then like I will show you the statement. That statement. Okay. If you want to say this F, that is the measurable set will be in this format, or this format, this or this. Okay, any one of this format. If the F is in this format, then you can say that F is measurable actually. So that is why here you are writing that is to prove line. for a number C, this is measurable. If you are saying this is measurable, then obviously you can say F is measurable. So let N and you are taking two natural numbers, any natural number that are N and K, and let also you are taking F J of X less than C minus 1 by N for all J greater than or equal to K. Okay, you are taking Fj of X value like this, Fj of X less than this. If if the value of Fj of X is less than C minus 1 by N, you can say Fj of X is measurable, because in that proposition, if it is in this format, then you can say that is also measurable. You will say there. So that is why in the next line you are saying, since Fj is measurable, you can say X belongs to A such that Fj of X less than C minus 1 by N is measurable. Okay, you are writing in the with set braces. Okay, you are writing in this format. You are saying this is measurable, it means this will also measurable. That is what you are saying. And in the next line what you are saying is, we know that intersection of countable collection of measurable set is measurable. You have a proposition. Okay, you have proved this sentence, this statement in another one proposition also. You are using that here. Okay, so intersection of countable collection of measurable set is measurable. Therefore, you can write like this. With intersection, you are writing this, and you are saying this is measurable. Now you are going to say union of countable collection of measurable set is measurable. Therefore, you are writing like this. Now you are writing this like this, because this and this will have the same meaning. That is why you are writing like this. Just please memorize or recall it again and again, so that you don't forget for the examination. X belongs to A such that F of X less than C is equal to union 1 less than or equal to K, N less than or equal to infinitive, intersection of this value. Okay, so you can write this like this, because this and this will give you the same meaning. And I could not explain you that well, because I not even have the proper understanding on that. Okay, when I come to know about it, surely I will explain you. Also, we know that union of, so from this you are going to say this is measurable. Okay, to say that you are taking a proposition that you have proved already, that is union of countable collection of measurable set is measurable. So using that proposition, you can say this is measurable. If this is measurable, then you know that this will also be measurable. Therefore, if this is measurable, then you can say F is measurable. This is what we have to prove, right? In the statement, they asked us to prove this. So finally, you have proved this. So this the proposition comes to an end. Okay, this is how you are proving. First you have to, let me revise it within 1 minute. So first you have to you have to prove this. To prove this, you are taking Fj of X less than C minus 1 by N, and you are writing this with this, and you are saying this is measurable, and then you are using two proposition here. They are intersection of countable collection of measurable set is measurable, and union of countable collection of measurable set is measurable. To use these two propositions, you are writing according to that. Okay, you are writing this according to that, so that finally you can say F is measurable. Hence the proof.